Calcwise.
I'm Sir Joseph.
I'm Mom Joanna. I'm Mom Kathleen. I'm Mom Jess. And I'm Mom Lay.
In exploring the convergence, of course, we need to know its importance. So understanding the convergence helps us to know where the power series is valid and useful, which is important in the calculus, physics, and engineering.
Before we start, let us first define the concepts we are going to encounter as we dive later in our solution process. Power series, radius, and interval of convergence. Number 1. A power series is an infinite series in the form summation of a sub n times the quantity of x minus c raised to n, where a sub n are the coefficients, c is the center, and x is the variable. Number 2. The radius of convergence r tells us how far from the center the series converges. Number 3. The interval of convergence is the set of x values where the series converges. Now that we are done defining the concepts, let us now move on getting to know about the ratio test. Here are the ratio test formula. Limit n approaches to infinity, a sub n plus 1 over a sub n is equal to L. The condition we need to remember, if L is less than 1, it converges. And if L is greater than 1, it diverges. And if L is equal to 1, it is inconclusive.
For our first example, let's say we have a power series from 0 to infinity of x plus 3 raised to n all over 4n factorial. So let's start with the ratio test. The limit as n goes to infinity of the absolute value of a sub n plus 1 all over a sub n, we need to see where it's less than 1 where the series converges. So, a sub n plus 1, you are going to replace n with n plus 1, so it's x plus 3 raised to n plus 1 all over 4 times n plus 1 factorial. And a sub n is the original expression, which is x plus 3 raised to n all over 4n factorial. So let's take the limit as n goes to infinity of a sub n plus 1 divided by a sub n, which is x plus 3 raised to n plus 1 all over 4 times n plus 1 factorial divided by x plus 3 raised to n all over 4n factorial. So let's simplify the expression. X plus 3 raised to n plus 1, we could say that as x plus 3 raised to n times x plus 3 raised to 1. And then 4 times n is equal to 4n, and 4 times 1 is equal to 4 factorial. We're going to change division to multiplication. So we're going to get the reciprocal of the second fraction, so it's 4n factorial all over x plus 3 raised to n. Next is, we are going to get the factorial of 4n plus 4, which is 4n plus 4 times 4n plus 3 times 4n plus 2 times 4n plus 1 times 4n factorial. And then, let's cancel x plus 3 raised to n and 4n factorial. So the constant here is insignificant, so let's multiply the remaining, which is 4n times 4n times 4n times 4n is equal to 256n raised to 4. So this is equal to the limit as n goes to infinity, and then we have absolute value 1 over 256n raised to 4 times x plus 3. So basically, separated x plus 3 all over 256n raised to 4 into those two parts. As n goes to infinity, what happens to 1 over 256n raised to 4? So that's going to 0. And 0 times x plus 3 is equal to 0. Since the ratio test gave a limit of 0, The power series converges for all values of x. The radius of convergence is infinity and the interval of convergence is negative infinity to infinity. Negative infinity and infinity.
So for this example, we have the power series of n plus 4 factorial times 3x minus 6 raised to n. Feel free to pause the video to try this example and answer it on your own. The first thing that we're going to do is find the value of c. By doing that, we're going to equate this 3x minus 6 by 0. So 3x is equal to 6 and divide both side by 3, and then we're left with x is equal to 6 over 3 or 2. Our x is 2, and since x is also equal to c, so we have the center which is 2, and then we're going to find the value of a sub n plus 1. So here, for every n variable that we see, we're going to add plus 1 to it. So n plus 1 plus 4 factorial times 3x minus 6 is to n plus 1. Next is we're going to find the value of a sub n. And here, the value of a sub n is this original equation. So n plus 4 factorial times 3x minus 6 raised to n. And in this equation, we're going to use the ratio tests, which is the limit of absolute value of a sub n plus 1 all over a sub n as n approaches to infinity. So we're just going to copy the value of a sub n plus 1. N plus 1 plus 4 3x minus 6 n plus 1. And then the value of a sub n plus 4 3x minus 6 raised to n. We're going to simplify this equation, and n plus 1 plus 4 is equal to n plus 5 factorial, and then copy this equation and our denominator, tx plus minus 6 is to n plus 1, n plus 4 factorial 3x minus 6 raised to n. And we're going to expand this n plus 5 factorial, so n plus 5, n plus 4 factorial, and then distribute this exponent 3x minus 6 raised to n times 3x minus 6 raised to 1. Then copy the denominator, n plus 4 factorial 3x minus 6 raised to n. And we're going to cancel out n plus 4 factorial and 3x minus 6 raised to n. And then we're left with n plus 5 times 3x minus 6. The next thing that we're going to do here is put this equation in front, 3x minus 6 as limit of n plus 5 approaches as n approaches to infinity. And then let's just copy this 3x minus 6 limit of n. If we substitute n with infinity, infinity plus 5 is infinity. 3x minus 6 times infinity is equal to infinity. And if we plug in the x value here in this equation, 3x minus 6, our x is 2, 3 times 2 is 6 minus 6 is equal to 0. So our r is 0, and the interval of convergence is the center, and our center is 2.
And that's it. Now you know how to find the radius, center, and interval of convergence using the ratio test. Try more examples on your own and checking those endpoints carefully. If you found this helpful, ay marami pa kaming ibabahagi sa inyo. Kaya watch out for our next episode. Kaya hit like, subscribe, and hit the notification bell to to get more updates on our videos and work calculate your tutors. Bye-bye.